Hey everyone, today is Friday 5/21 and we're just going to go over the bridge project, the criteria, the constraints, and kind of the outline of the timing of the bridge project. Okay, so just a quick reminder of the engineering design process steps. So we're going to run through a whole engineering design process, except we probably won't have time for a redesign on the bridges, and people at home only have so many materials for it. So remember that it starts with defining the problem, researching the problem, brainstorming solutions, and choosing the best solution. We're going to try and get all of those 4 steps done today, and then we're actually going to spend a couple of weeks creating a prototype. Okay, so defining the problem. The goal of this is that you will build a bridge that can cross a 12-inch divide. So remember, if it has to cross a 12-inch divide, it needs to be longer than that, probably at least 14 inches, because the gap is actually going to be 12 inches and you need it to be able to stay outside the gap. It needs to be able to hold a dead load of at least 10 pounds. That's 4 smallish textbooks. And it needs to cost less than $5 million to construct. Obviously, that's not a real $5 million, but I have the prices of each of the things. We're kind of pretending that this is a full-size, or that we're building a model for a full-size bridge. So you'll need to do some budgeting to make sure that you are coming in at less than the $5 million mark. And then it also just needs to be neat. There's each of these requirements are on a rubric, and so neat design is part of the rubric. It just needs to be, not a super messy or sloppy design in the end. I also wanted to clarify one thing on this. So you should not be building a beam bridge for this. These are not very attractively designed, so you would not get very good credit on the neatness score. And also they're just really easy, so I just don't allow them, because you can just slap a bunch of popsicle sticks together and call it a day. You can build that in like one lesson if you wanted to. So if you do for some reason still decide to go for that, just know that the maximum grade that you would be able to get would be a B. So that's, even if you do the other things perfectly, you would still only be able to get a B if you build a plain beam bridge. All right, so the materials, those of you who are at home already got these. So the beams are those extra wide popsicle sticks. Each stick costs, in our fake money, our budgeting, $20,000. The welding materials, aka glue, costs $1 million for one bottle. If you end up getting a refill, again, that's only going to be possible if you're at school. That's another $800,000. So it's pretty expensive. Just be careful how much glue you're using as you work through it. And then there's some clamps. These are just binder clips. So the small clips you can rent for $50,000, and the large clips you can rent for $100,000. These should not be part of your final design, like they should not be included when we actually test the bridges, but clamps can help to hold things together as the glue dries, so you can think about whether you want to use them or not. All right, so next steps are going to be researching, brainstorming solutions, and choosing the best solution. We're going to try and get that stuff done in class today. So we're going to move through these pretty quickly. Obviously, real engineers are spending a lot more time on the researching and the making solutions part of this, but we're going to do this quickly. So use the internet for your research. We are not the only people who build popsicle stick bridges. A lot of students have done this in the past. So there's a lot of material on the internet about how to build these well. Use that. That is not cheating. That's part of the process here. You are welcome to search up best popsicle stick bridge designs. That's a really helpful thing to do. And or you can search for real bridge designs to try and get some ideas about how to either make them like attractively designed, like some good architecture, or just to see what helps make a bridge, a real bridge, strong, because some of that will translate into the popsicle sticks. Let's see here, you don't need to worry too much about plagiarism with this, because we're building a thing. It's not possible to exactly copy somebody else's building. So make sure you're crediting where you get your ideas when we do this research step. Just make sure you include the links, but don't be afraid to learn from other websites. and other students who have done this project before. Okay, after we do the research, you're going to brainstorm a few solutions. So you will sketch at least 3 different ideas for how you could build a bridge. These can be really quick sketches. I am not very good at drawing, so I don't hold anybody to a very high standard on the drawing, but we should have an idea of what your bridge might look like when it's finished. And then you're going to describe the one that you are going to try and why you are going to try it. So you're going to choose one of your solutions and explain why you want to go with that one. So we'll be doing all of this in class today, and this assignment isn't actually going to be due until the end of the weekend in case you want to take a little bit of extra time on it. And then we are going to get started on building when we get back on Monday. We're going to work on building our prototypes based on our initial designs. All right, if you have any questions, leave them in either the Do Now or this homework assignment. Go ahead and fill out the form, and I will see you in class.